Well, ahoy, mateys! We're going to do 8.2 today. It's all about how to find surface area of 3D figures. So what surface area is basically it's the sum of the areas of all the faces. And you can use what is called a net, which is a two-dimensional representation, to find surface area. It'll all make sense by the end of the video, hopefully. So basically, your first question to start thinking about is, how are the concepts of area and surface area similar? How are they different? And then what kind of units are used to measure surface area? So the first question I'm going to answer for you. So for area, if I have the area of, let's say, this piece of paper I want to find, I would find the length and the width, and I would multiply length times width, and that would give me the area of that paper. When I'm talking surface area, okay, so if I have this vintage Captain Crunch box here where you can order a Pokemon watch, and I want to find the surface area of this, what I'm doing is I have to find the area, just like I did of that piece of paper, using the length and width for the front of the box. Okay, but then I would also have to find the area of the back of the box, and the top, and the bottom, and the left, and the right, and I would add up all 6 of those areas. That is the surface area. Okay, so the difference between area and surface area is for two-dimensional shapes. Surface area is three-dimensional shapes. Okay, what kind of units, though, are used when you're finding surface area? It is square units. Okay, just like when you're finding regular 2D area, the answer will be square units. It's how many squares would I have to cut out and lay over to make this entire thing covered up. So that is what we're doing today, is surface area. It's basically just individual areas all added together. So let's jump to this warm-up because we have to practice how to find areas. So I'm going to test you right now on your area finding abilities. So for this first question, what is the area of this rectangle? Okay, so it's 4 times 15, which is 60 square centimeters. Area is always square units, no matter 2 dimensions, 3 dimensions, no matter what. It's always square units. One thing to remember, when you're writing on paper, don't write the square next to the 60 because that would mean 60 times 60. So if you're writing it out, you can either write inward 60 square centimeters or 60 centimeters squared like that. Okay, what is the area of that triangle? So first, for triangles, you will multiply the base times the height. It's 12 times 8. That is 96. But then you divide by 2 because triangles are half the size of a rectangle. So you end up getting 48 square inches for that one. Number 3, what is the area of this square? 6 times 6 is 36. So 36 square feet. And what is the area of this triangle here for the 4th one? This one's slightly tricky because they give you a number you don't need. So anytime you're doing area of triangles, you need the base and you need the height, and that's it. So the base is 8, the height is 3, the 5 doesn't matter if you're doing the area. So you do 8 times 3 is 24, but cut it in half because for triangles, it's always 1/2 the base times the height. So it's 12 square centimeters. If you have any questions or you have struggles with doing areas of these shapes, you need to see me or do some more practice because you have to be able to do these to do surface area. Surface area is just doing a bunch of areas and adding them together. All right, so now we're going to talk about the concept of nets. So the way this works usually is when they make these boxes in the factory, they don't start off as 3D boxes. They start off as flat rolls of cardboard, which they cut into individual nets, they're called, and then they fold them and they glue them to make those boxes. So this takes a little while to load. So when you're finding surface area, it also helps to start with the 3-dimensional shape and then break it down into a flat pattern or what's called a net. So let me scroll down. By the way, this is your actual textbook. If you ever want a physical copy, you can pick one up at the school. This is also available digitally on the resource page that we include every week on the slideshow. So for surface area, a good way to do this is to make flat patterns or nets. So if you take your 3D shape and break it down into its 2-dimensional flat pattern or net, that will help you find surface areas because then you just have to add up all of the individual areas. Boom, done. So if you're breaking down a rectangular prism, it'll usually break down into this sort of flat pattern or net. And then you can just find the areas of the individual parts of it, add them together. There's your surface area. For triangular prisms, it'll usually break down into something that looks like this. It'll have 2 identical triangles and then 3 frequently different rectangles. So let's do one quick example. Actually, I want to show you one more visual because it's nice and colorful and pretty. And if you are a note taker, let me zoom in a little bit. This is something you might want to pause and jot down in your notes. So anytime you are doing a rectangular prism, it's going to have a top and a bottom that will be identical. It'll have a left and a right that'll be identical, and it'll have a front and a back that'll be identical. So rectangular prisms are made up of 3 identical pairs of faces. Okay. You have a pause button. So if you wanted to take notes, you could just pause it. Okay, and then for triangular prisms, we have the same deal. Triangular prisms are a little trickier because it's not so identical. The only things that are always identical on triangular prisms are the front and the back triangles. Okay, frequently, all 3 of these faces will be different. So frequently, this side, and the bottom will all be different sizes. So now we're going to move on to an example. So for example number 1, this is the surface area for a rectangular prism. It's also nice and colorful and pretty, and it takes forever to load for some reason, but here we go. All right, so find the surface area of this rectangular prism. First thing I want you to do is find the area of the front of this prism, just the green rectangle in front. Hopefully you did 7 times 3 and got 21 square inches. So the area of the front face is 21 square inches. What is the area of the back? Also 21 square inches. Well done. Okay, so usually when you're solving problems, the best thing to do is to get some paper and pencil and draw a flat pattern, draw a net to find the area for each face. And then label it all nicely, okay? So here, if you break this box down, this rectangular prism down, it will give you 6 faces. So you have the top and the bottom. Those are both 7 by 4. Okay, and they labeled them clearly here on the side in addition to drawing this picture here too. Okay, the front and the back we just did as 7 times 3. So the front and the back are both 21. And then the 2 sides is 4 by 3 for the left and the right side. So what is the total surface area for this rectangular prism? You add them all together, you find the sum, and you get 122. So 122 square inches is the total surface area. It's how many squares you would have to cut out and glue together to cover that or build that rectangular prism. Okay, we have one last example, then it'll be time for you to practice on big ideas. There are 2 big ideas again. There's 8.2a and 8.2b. 8.2 is standard, 8.2b has a mild and spicy. So here, find the surface area of this triangular prism. I'm going to start you with a tough question. What is the area of only the blue rectangle on the top, the little ramp there? Okay, this one I intentionally try to fool you because it puts the 5 right here. 5 is the height. This blue rectangle has 8 for the width. So it's a length of 13 and a width of 8 because it's the same as down here. So the blue rectangle is 13 times 8, 104 square centimeters for the blue rectangle. Okay, so it's kind of tricky to picture there. That's why it is useful to make a net. So draw it flat. Okay, so if you were to take this and cut it out, you'd have the blue rectangle, which is 13 by 8. You'd have the bottom, which they made red. That's 12 by 8. And then you have the front and the back are identical triangles. So the front and the back, you do 1/2 the base times the height. The base is 12, the height is 5. And then you have the yellow one on here on the side, which is a 5 by 8. There. Okay, so that's all 5 faces for that triangular prism. So what is the total surface area? You add them all together, and you get a grand total of 300 square centimeters. So that is what you'll be doing for 8.2, is you're going to have rectangular prisms like these boxes. You'll have triangular prisms like Toblerone boxes or like this here ramp. and you're going to have to find the surface area. So you're going to find out how many squares it would take to cover the whole shape. So it's basically breaking it into individual shapes, adding them all together. If you need help, you can rewatch the video, email me, come there on demand right after our live sessions. Go to the ASC to get some help. Google, but don't just think, oh, I don't. This is confusing in lots of shapes. Okay, use paper and pencil, draw these things out. Come see me if you need some help. Good luck, and I will see you during our next live session. Arr!